Bismillah ar-Rahman ar-Rahim. We'll start talking about these two sections. Actually, I will deal with them like if they are one section, because they are linked somehow. What we have in this section, which is the linear algebra part, these two sections, 4.1, 4.2. First, they define what they mean a vector in a three space R3. It just ordered triple of real numbers A, B, C. So we write V, A, B, C. Okay. So we see are the components of that vector. We know how to add two vectors. We just add the components. How to multiply a scalar by a vector. We just multiply the scalar by each component of that vector. Mainly, we are concerned about these two operations, which is the addition and scalar multiplication, and multiplication by a scalar or scalar multiplication. These are the two main operations usually we deal with. Okay, so also we can define the length of a vector, which is now a vector A, B, C. So it's just the length or the magnitude of a vector, which is the square root A squared plus B squared plus C squared, which is, we know that the vector is the distance from a point to the origin, which is A minus 0. We can say 0, 0, 0. If we do the distance, that will be the magnitude of the vector. Which is A minus 0 all squared plus B minus 0 all squared plus C minus 0 all squared under the square root. Okay, that's mainly just we start with this R2 or R3. Yeah, we can define R2 the same thing, or R3. Then we are concerned about the vectors. Are they linearly independent or linearly dependent? If you have two vectors, it's easy to figure out. Just if someone is one is a multiple of the second one, or the first one is a multiple of the second one or not. You can check it just by looking. And if I have this vector u and this vector u v, it's very clear that v is 5u. So it's a multiple of it. So they are linearly dependent. However, if you look at this vector and this vector, yeah, for sure, there is no way I can multiply one of them by a constant, and I get the other one. So they are linearly independent. So if you have two vectors, it's easy to figure out this one. But we want to make I mean, a way so that we can generalize it. Because this way, just by looking at the vector and see the scalar multiple of the other one, if it is two vectors, it's easy. But if it's three vectors, 4 vectors, 5, it will be very complicated to check. So we have what's called, I mean, we need to deal with it in this way. But I have this relation. The idea is what I have this relation. I will write AU plus BV equals 0. Also, if I have a third one, the same thing, I'll say plus CW equals 0. But now let us deal with 2 only. It means I have a system, and I need to find A and B. If A, the only solution, if the only solution of this solution, of this system, I mean, the only solution is A equal B equal 0, that means U and V are linearly independent. I call it Li. If there exists A and B, not both 0, then U and V are linearly dependent. U and V are linearly dependent. Okay, so if I can find A and B, not all zeros, at least one of them not 0, such that I have this relation, AU plus BV equals 0, then it means U and V are linearly dependent. However, if there is no possibility to have this relation, AU plus BV equals 0, unless A is equal to B is equal to 0, then we call the two vectors linearly independent. Then the two vectors are linearly independent. I wish it's clear. You know what? Let me add one page. What I will do, I'll try to apply that for these vectors, which I know this is very clear. This is dependent and this is independent. So let us see what will happen. I have u is -1 and 3, and v is -5 and 15. So I want to solve this system. Let me do this one here. I have AU plus BV equals 0. So I have what? A -1 and 3 plus B -5 and 15 is equal to the 0. 0 by mean it's 0, 0, since I am in R2. So that means I have the equation -A -5B equals 0. Or since I'm doing it for the first time, let me do it in details. So I have -A -5B. They have 3A plus 15B. That's equal 0, 0. So I have two equations, -A -5B equals 0, and 3A plus 15B equal to 0. We have two equations, two unknowns. How to solve them? This is what we need from chapter 3. So as it was explained, chapter 3 is just a tool for the other chapters. Like in this one, now to solve the system, how I can do it, the review of chapter 3 will tell me either I can do substitution, elimination, can do Gaussian elimination, the way you like it. You have two equations, two unknowns, solve it. So I can rewrite this one as A plus 5B equals 0. And this is 3A plus 15B equals 0. So I have this system. Multiply by the first equation by -3 and add, I have 0. -3 and add, I have another 0 equals 0. So I have actually only one equation, that A is equal -5B. So actually I have infinitely many solutions for this system. And so that means what? It means I can find A and B not both 0. So I can let, for example, B equal 1. So A equal -5. So according to this definition, I am in this stage. There exists A and B not both 0, at least one of them non-zero. Says that AU plus BV says that AU plus BV equals 0. That means what? U and V are linearly dependent, which I know it. Which that. So I have -5U plus 1 times V is equal to 0. Or I can write V as 5U, which I know it by just looking at the vectors. Yeah, this is times 5 will give me this one. Okay. So this is the case where I'm getting a solution other than A is equal to B is equal to 0. Let me do the second one so that I will make it very clear. I have U is 3 minus 2, U 3 minus 2, and V, what is 5 minus 7, I think. Yeah, 5 and -7. Let me do the same thing. So I need to check. It's very clear for me. These two vectors are linearly independent. I mean, there is no way I can write one in terms of the other one since they are only two vectors. So I have AU plus BV equals 0. That means what? A 3 minus 2 plus B 5 minus 7 equal to 0, 0. The vector 0 since I'm working in R2. Let me write the equation right away. I have what? 3A plus 5B equal to 0, and -2A minus 7B is equal to 0. How to solve the system? As I said before, you can try any method of methods we learn in chapter 3. I can do substitution or I can do elimination. And for example, I can multiply the first one by 2 and the second one by 3 to get rid of A. So I have 6A plus 10B equals 0. I have minus 6A minus 21B equals 0. If I add these two equations, I'm getting what? I'm getting minus 11B is equal to 0. That means B equals 0. Plug it there. That means 6A is equal to 0. So A is equal to 0. So the only solution I'm getting is A is equal to B is equal to 0. If that is the case, according to this definition, if I have the only solution is this, that means the two vectors are linearly independent, which I know it means U and V are linearly independent, which I know just by looking at these two vectors. So this is the way to judge the two vectors are dependent or independent. This is like for 2 by 2. This can be generalized to three vectors, 4 vectors, and this is what we will do later after we go to R3 or after. We can generalize it actually not only to 3 vectors, to 4, and that will be explained actually in 4.3, 4.4, and so on. Okay. Now the other things we need to figure out. Sometimes I want to write a vector as a linear combinations of two vectors or 3 vectors or 4 vectors. What's the meaning of that? We say a vector W is called a linear combination. Don't forget, always we are concerned about 2 operations: addition and scalar multiplication. We're not concerned about product, quotient, all of these things we're not concerned about. We are concerned only about these 2 operations: addition and scalar multiplication. So I have addition and scalar multiplication times the constant. So this is these are the 2 most important operations. So we say W is a linear combination of 2 vectors if there exist scalars A and B. Says that W, I can rewrite it as in terms of U and V by this linear operation. AU plus BB equal W. Okay, let me do this problem. I want to express W as a linear combination of these 2 vectors. That means I need to write W as AU plus BV. Here I'm writing it as AU plus BV equals 0. No, in this one I want to write it as another vector, W. So what we have, we'll do the same thing actually. Now I'm looking for A and B. So I have 11 and 4 equal A VU plus B VV. Equals what? 3A, let me write it this way. 3A minus 2B minus 2A plus 7B. So I have 2 equations. 3A minus 2B equal 11 minus 2A plus 7B equals 4. So I have 2 equations, 2 unknowns. Do it the way, you need to solve it the way you like. Just I'm looking for A and B, 2 equations, 2 unknowns. Like what we did before, I can multiply this by 2, multiply this by 3, so I get rid of A, so that I can solve it. That give me what? 6A minus 4B equal 22. And I have minus 6A plus 21B is equal to 12. Cancelled, add those, I'm getting what? Minus 4, that will be 17B is equal to 34. So B equals to 2. Plug it there. So I have, or I can plug it here, maybe better. Can plug it in any of these equations. So since I have 3A minus 2B equals 11. So let me plug it here, better. So I'm getting what? 3A minus 4 is equal to 11. That means 3A is equal to 15. So A is equal to 5. A equals 5, B equals 2. That means what? That means W, which is 11 and 4, is what? Is 5 U plus 2V. B is 2 and A is 5. And I can see it easily. Yes, I need a space. This is 5. What is u? U is 3 and minus 2. And 2 is minus 2 and 7. Look at this. 5 times 3 is 15. 2 times minus 2 is minus 4. 15 minus 4 is this 11. And look at the other one. 5 minus 2 is minus 10. 2 times 7 is 14. Minus 10 plus 14 is this 11. This 4. So this is correct. W is 5u plus 2v, and can check it easily. So I express W in terms of these two vectors, u and v, as a linear combination. As I said, now we are working only with the addition and the scalar multiplication, not the other operations. Now we'll extend that idea of linear dependence, dependence or independence to the three vectors. If I say three vectors, the same idea, but now the equation will be AU plus BV plus CW. Since I have three vectors, U and W. We say they are linearly dependent. If I don't leave there is scalars, not all zero, at least one of them non-zero. So that I have this relation. AU plus BV plus CW equals 0. What about linear independent? If the only solution of this equation, where I have system now of three equations, is A equal B equal C equal 0, then we call them linear independent. And when they are, I can find at least one of them is non-zero. If all of them non-zero, it's okay. Just at least one of them is non-zero, then it's called linear dependent. It will be called linear dependent. That idea of making them, all of them is equal to 0, and that means this is the only solution, that will lead us to this method to discuss, to prove they are linear dependent or dependent, which will make it easier. Just I need to find the determinant. I list the vectors u, v, w. Just I list it u, v, w. And then find the determinant of that. If the determinant not equal to 0, then we call them linear independent. Look at this f and double f, so I need both sides. And if the determinant is equal to 0, then they are linearly dependent. And let me apply that to the two easy examples we did before, which is minus 1, 3, minus 15, minus 5 and 15. Let me do it here. I have u minus 1, 3, and v minus 5 and 15. By the way, this can be generalized to 3 vectors, 4 vectors, 2 vectors, anything else. So what I will do, I will find uv, not u times v, u as a vector, v as a vector. That will be minus 1, 3, minus 5, 15. What are we getting? We are getting minus 15 plus 15, which is 0. If we are getting 0, it means linearly dependent, which I know it. I know in this one, they are linearly dependent. These two vectors are linearly dependent. And the same thing for the other two vectors, which is 3 minus 2, 5 minus 7, 3 minus 2. Yeah. The other two vectors, 3 minus 2, and 5 and minus 7. What will be now uv? That will be 3 minus 2, 5 minus 7. That will be minus 21 plus 10, which is minus 11. The most important thing is not equal to 0. That means u and v are linearly independent. This is which we know, they are linearly independent. Not only that, if the vectors, if I have 3 vectors in R3 and they are linearly independent, then they will make what's called the basis for R3. What they mean by a basis, I did not define it here. Let me define it here. Let me give a space for that one. And define what's called, what's the meaning? What's the meaning of a basis? We say a basis for R3 is what? I have to the definition of the basis. Actually, it will be defined in 4.4. But let me explain it quickly. It has two things. Any vector in R3, any vector W in R3, let me say U and V. Yeah. The problem is that U, V, and W as a set is a basis for R3 if what? If any vector W in R3, any vector W in R3 can be expressed as a linear combination of U, V, and W. And so I call this T. Yeah, any vector T in R3 can be expressed as a linear combination of U, V, and W. This is the first condition. The second condition, U, V, and W are linearly independent. Then we call it a basis. So the main idea is that for R3 or for any vector space, I want to find vectors which can generate all the elements in that vector space. So any vector can be generated by these three vectors as a linear combination. And not only that, I don't want to see a repetition of these vectors. Because of that, I want them to be linearly independent. This theorem is saying what? If there are three vectors in R3, we'll talk later about the dimension, all of these things, then they are linearly independent, then that is enough for me to say they are a basis for R3. So no need to, so this one will come if the three vectors are linearly independent. Just to give you, just an example, easy example for R3. I know I, which is 1, 0, 0, and V and J, which is 0, since I'm not using an arrow, okay, and K will be 0, 0, 1. These three vectors, I know if any vector A, B, C in R3, then that vector, let me call it V, then that vector V, which is A, B, C, I can get it from these three vectors through A times I plus B times J plus C times K. You know what, let me use the arrows. I think it will make it easier. So because of that, and they are linearly independent, and I, J, K, they are linearly independent because you can check it easily. I have 1, 0, 0, 0, 1, 0, 0, 0, 1. This determinant is 1 not equal to 0. So they are linearly independent. So any vector can be generated by these three vectors, and they are linearly independent, so they form a basis for R3. Actually, I need only this, since there are three. But now I prove both of these two conditions, which is the main conditions for the basis, which will be explained in 4.4 in details. So what we want you to know in this section, how to say three vectors or any number of vectors in Rn. Actually, only three vectors, because Rn will be discussed in 4.3. This is what's not good about this book. Yeah, it will go back and forth. Okay. So I have three vectors. When they say linear independent, either through this system or through the the determinant, which will make it easier. This is what we wanted to know. And not only that, if they are 3 and they are linearly independent, then that will be enough to say they are bases for R3. Okay. He said determine whether the vectors, these 3 vectors, are dependent or independent. If they are dependent, it means I can write one in terms of the others. It means they are scalars A, B, C, not all zeros, so that I have this relation. Then find A, B, C. Okay. How to say they are dependent or independent? I have these vectors. To say they are dependent or independent, linear dependent or linear independent. How to do it? Through the determinant. Just I list the vectors. This is U. This is V. This is W. You want it as a row or as a column, it will be the same, because you know the determinant of the matrix is the same as the determinant of its transpose. So I deal with it as a row or as a column, it will be the same thing. Okay, so I want to check this determinant. If this determinant is equal to 0, then linearly dependent. If this determinant not equal to 0, then they are linearly independent, like what we said here. Check their determinant not equal to 0, independent, equal to 0, so they are dependent. Okay, let us see. Let us do the calculation. We know how to do the determinant, and as I said before in solving the system, now finding the determinants, this is what I need from chapter 3, how to find the determinants, which I think it was explained to you, or you can review it from the, because it was done in the prep year. Okay, so I need to do this calculation. As usual, to do the determinant, I need to make more zeros. So I want this to be 0. So I multiply by -2 the first one, added to the second one. I have, let me write it here, -2 R1 plus R2. I'm getting what, 0, -2, that will be -5, -2, that will be -15. Then also I want this to be 0, so I multiply 3 this time, plus R3. So I'm getting 0. 3, 9 minus 2, that will be 7. 15 plus 6, that will be 21. So that give me what? I have 1. I cancel this with this. So 1 times this determinant. Just to remind you about how to do the calculations. That give me -5 times 21 plus 15 times 7. It's minus 15. You notice this is -5 times 3 times 7, and this is 5 times 3 times 7. So the result is 0. That means what? U, V, and W are linearly dependent, since the determinant is equal to 0. If the determinant not equal to 0, then for sure they are linearly independent. So he said, if they are linearly dependent, he wants me to find A, B, C, because it means I can find A, B, C, so that I have this relation is equal to 0. That's the main definition of linearly dependent, if you remember. To say they are linearly dependent, if I have this relation, at least exists scalars A, B, C, not all 0. So he wants me to find those A, B, C. Okay, so what I will do, I solve the system. Like what we did before. I have A times U plus B times V plus C times W. That should equal to what? 0, 0, 0, since I am in R3. So I have this equation. A plus 3B plus 5C is equal to 0. I have 2A plus B minus 5C is equal to 0. I want to write this system as equations now. I have minus 3A, the last component, minus 2B, okay, plus 6C is equal to 0. I want to solve this system for A, B, C. I did like before. I can do it by Gaussian elimination or by the substitution. I get rid of A. I have what? A plus 3B plus 5C equal to 0. Multiply by -2 and add. That will be 0. -2 and add, so it's no need for it. -2 and add, that will be -5B. -2 and add, that give me minus 15c is equal to 0. Now I add times 3 and add, that will be 0 خلاص. 9 minus 2, that will be 7b. Multiply by 3 and add 15 plus 6 plus 21. C equal to 0. Actually, I can rewrite this system. As I said, you can do it by Gaussian elimination. You can do it by many methods. 5c equals 0. I can divide by minus 5. I'm getting b plus 3c equal to 0. And the same thing here. I'm getting b plus 3c equals 0. Now do the Gaussian elimination again. The first equation will be the same. So I have b plus 3c multiplied by minus 1 and add. I'm getting 0 equals 0, which means nothing here. So it means I have now two equations, 3 unknowns. So I can write all of this in terms of c. So b equal minus 3c. Plug it there. I'm getting a is what? Minus 5c minus 3b, which is where b is minus 3. Huh? So yeah, let me write it. Minus 5c minus 3b. And what is b? Minus 3c. So it will be minus 5c plus 9c. That give me 4c. So now if I choose c, you can choose c any value. Choose c other than 0. C equal 1. B would be what? Minus 3. And a will be equal to 4. So these are the three values, A, B, C, where I have 4u minus 3v plus w is equal to 0. So I have this relation, and which is easy to check. Just plug the u. I can check for the first component. I have 4 minus 9 plus 5. 4 minus 9 is minus 5 plus 5 give me 0. You can check the other components. Determine whether the vectors, actually it is the same question. Yeah, exactly the same questions. But what they want, if they are linearly independent, then find constants. C1 and C2 says that W is C1 plus C2V. I know that in for u, this is the same question. I know in for u minus 3V plus W equal to 0. But now he wants me to do one more step where I need to write W in terms of the other two. So I can rewrite that W is what? 4V, he wanted V plus W. So 3V, huh? I took these vectors to the other side. So I'm getting 3V minus 4U. So my C1 is 3 and my C2 is minus 4. So this is the same, actually it's the same vectors, huh? Yeah, I meant it's the same vector, but now I want to go one more step where I write W in terms of the other. Just I move these to the other side. Now this is another question. Determine whether the following vectors are linear dependent or linear independent. If they are linear dependent, then write one of them as a linear combination with the other. Okay, we'll do the same thing. I have the determinant UV, UV, W. Okay. I need to increase the zeros. I think I will take this. I'll interchange the first with the third. That will be minus. Interchange. Okay. 1 minus 1 minus 1. 0. 1 minus 2. 2 minus 3. 0. Now multiply the first one by a minus sign, by minus 2, and add it to the third one. Times minus 2, that will be 0. Minus 2, that will be minus 1. Minus 2, that will be 2. Okay, so that will be what? 1, 2, minus 2, which is 0. So they are linearly dependent. Now I need to solve the system to find A, B, C. They get as right they write one of them as a linear combination of the other two. So I need to reach this. W is a linear combination with the other two. Okay, so I need to do what? Like what we did in this one. I need to write it. I need to solve the system. AU plus BV plus BV, AU plus BV plus CW is equal to 0. I need to solve this system. How to solve this system? I have A, let me write it this way, plus B. Also write it as a vector, it will be the same. Let me write it as a vector. Since I did it as a row vector, now let me write it as a column vectors. Plus B minus 3, 1 minus 1, plus C 0 minus 2 minus 1. That should be equal 0, 0, 0. So what are the equations? I have 2A minus 3B is equal to 0. I have no A, B minus 2C equals 0, and I have A minus B minus C is equal to 0. I can interchange these two equations, 1 and 3. I have, yeah, you can solve it the way you like. Okay, you can solve it the way you like. So I have now 2A minus 3B equal to 0. Now multiply the first equation by minus 2 and add it to the third equation. I'm getting what? Minus 2, that will be 0. Minus 2, that gives me minus B. Minus 2, minus 2C. Minus 2 times minus C, that will be 2C plus 2C. Now, you notice, now if I want to deal with the second, with the third, so this is B minus 2C equals 0. Multiply by 1 and add, that will be 0. Multiply by 1 and add, that will be 0 again. So 0 equals 0. So the third equation will be gone. So for now, I can do the back substitution. So I have B equal to C and A equal B plus C, which I can write in terms of C as 2C plus C, which is 3C. That means if I let C equal 1, then A will be equal 3 times 1, which is 3, and B is equal to 2. So the relation which I have is what AU, AU, which is 3U plus 2V, where B is V, plus W is equal to 0. That means I can rewrite W as what? Minus 3U minus 2V. So I wrote W in terms of the other two vectors, which is, so W is minus 3U minus 2V. I want to be sure about the calculation. Yes, I'm getting the same answer. So I write W in terms of the other two vectors. Now let me take an example where they are linearly independent. So what kind of question we are expecting? Now, if they are linear independent, I want to write them one in terms of the other. Now, if they are linearly dependent, or he said not only that, form a basis. Okay, so I need to check if they are linearly three vectors and they are linearly independent, then they form a basis. Don't forget this. He said if there are three vectors, this is most U, V, W, 3, count them 3 in R3, and they are linearly independent, then they will make what? A basis. So what I will do, first I need to show U and V and W, show that U, V, and W are linear independent. How to do that? Through the determinant. So I need 132, 287, 179 to show that this determinant not equal to 0. So I get rid now, the same thing we did before. I try to get rid of these 3 and 2, make it 0. So multiply by minus 3 and add, that will be 0. minus 3 and add that will be 2, minus 3 and add that will be 4. Now minus 2 and add that will be 0, minus 2 and add that will be 3, minus 2 and add that will be 7. So I'm getting what? 14 minus 12, which is 2, not equal to 0. That means what? U, V, W are linearly independent. If they are 3 and they are linearly independent in R3, that means what? U, V, W form a basis for R3. Forms a basis for R3. So what kind of question we are expecting if they form a basis is I want to be sure that any vector in W can be written as a linear combination of these three. Because if that he said express T, he give you a vector as a linear combination of these three, since they form a basis. I'll do the same thing. I need to write T as a linear combination AU plus BV plus CW. And I'm looking for A, B, C. So that give me what? A times U, 132, plus B times V, 287, plus C times W, 179. So what kind of equations they have? I have, let me do it the other way. A plus 2B plus C is equal to my, and they have 3A plus 8B plus 7C is equal to -1. Second component, they are equal. And then the third one, I have 2A, third component, plus 7B plus 9C, that should equal to 3. So I need to solve this system. Let me try to solve it quickly. So I'll do what? Yeah, the first equation, I keep it the same. I'm looking now for A, B, C. So multiply by -3 and add, that will be 0. -3 and add, that will be 2B. -3 and add, that give me 4C. Okay, -3C plus 7C. -3 and add, that will be 9 minus 1, that give me 8. The last one, add by times -2 and add. First equation times -2 and add it to the third one, that will be 0. -2, that will be 3B. -2C plus 9C, that give me 7C. -2 times 3, that will be 6, plus 3, that will be 9. So also I can rewrite the second equation, yeah, to make it easier, as B plus 2C, I divide by 2, equal to 4. So that will make it easier for me to do the calculation. So now I have this system, which is A plus 2B plus C equal -3. You can do it Gauss elimination, actually, or this way. Now multiply by -3 and add, that will be 0. -3 and add, that give me C. -3 and add, that give me -3. Since -3 times 4 is -12 plus 3, that will be -3. So I get C, plug it there. That give me what? B equal 4 minus 2C, which is 10. 4 plus 6, which is 10. Now I plug B and C there. I'm getting what? A equals what? -3 minus 2B minus C. So I have what? -3 minus 20 plus 3. That give me -20. So what are we getting? We are getting that T, so this is A, this is A, this is B, and this is C. So I have T, that means T A, which is -20 U, plus B, which is 10 V, -3 W. So it's -20 U plus 10 V minus 3W. So I can write T in terms of these three vectors, Yeah, another problem. These are just something more examples. Let me try to do them quickly. Express the vector T in terms of those things. So we'll have the equations. Let me write the equations quickly. I need AU plus BV plus CW is equal to T. This is the way to express T as a linear combination. This is what's the meaning of a linear combination of these vectors. So I have A 1, 2, 3 plus B plus C equals to 11 minus 4 and 10. So what kind of equation I have? I have A plus 3B equals to 11. I have 2A minus 2B plus 2C equal to minus 4. I have what? 3A plus B minus C equals to 10. And let me solve this system quickly. I have what? A plus 3B equals 11. Times minus 2, that will be gone. Times minus 2, that give me minus 8B. Minus 6 minus 2. Times minus 2, I'm getting plus 2C. Times minus 2 and add, that will be minus 26. Okay. Then times minus 3 and add, that will be 0. Minus 3 and add, that will be minus 8B. Minus, that will be minus C. Minus 3 and add, will be what? Minus 33 plus 10, that's equal minus 23. Now I can do this by 2. So I have what? A plus 3B equals to 11. I divide by minus 8. No, that will make it complicated. You know what? No need. Yeah, I can do it right away. I can get rid of B easily by multiply by minus 1 and added, that will be gone. By minus 1 and added, that will be minus 3C. By minus 1 and added, that give me 3. So that means C is minus 1. If C is minus 1, then minus 8B is equal minus 26 minus 2C. So minus 26 plus 2, which is minus 24. So B equals to 3. That's B, and that's C. What will be A? A will be 11 minus 3B, which is 11 minus 9, which is 2. So A is equal to 2. That means what? T can be written as A, which is 2 times U, plus 3 times V minus W. That would be the way to write, T equal 2U plus 3V minus W. Now I wrote T as a linear combination of the other vectors. 2 more to go. Then I will stop. Show that they form a basis. How to show that they form a basis. I need to check they are linearly independent. Since they are 3, I need only to check they are linearly independent. If they are linearly independent and they are 3 in R3, then they form a basis. How to check they are linearly independent? I'll do this. 3, 0, 1, 1 minus 1, 2. Do the determinant. The answer should be non-zero. Multiply by 2 and add, that will be 0. Multiply by 2 and add, that will be 6. Multiply by 2 and add, that will be 1. Multiply by minus 2 and add, that will be 0. Minus 2, that will be minus 5. Minus 2, that will be 0. So what will happen? That will be 0 plus 5, which is 5, not equal to 0. So that means U, V, W are linearly independent, and that means U, V, W, they form a basis for R3. Now I want to express T, which is this vector, 2 minus 7, 9, in terms of those U, V, W. So I need to write T, which is 2. I need to write T, AU plus BV plus CW. I need to find A, B, C. Since they form a basis, it means any vector in R3 can be expressed as the linear combination of those three. That means what? I have, let me do it quickly. I have A times U. So I have A, the first element, plus 3B plus C, the first component, I mean, is equal to the first component 2. I have minus 2A, no C, no B, I mean, minus C is equal to minus 7, the second component, and T. The third component, 2A, and they have plus V plus B. The third plus 2C is equal to 9. And to solve this system, we know how to do that. And get rid of, yeah, you can do it this way or Gaussian elimination, the way you like. Now times 2, that will be 0. Times 2, that will be 6B. Times 2, that will be plus C. Times 2, that's equal to minus 3. And this one times minus 2 now, that will make it 0. Times minus 2, that will be minus 5B. Times minus 2, that will make it 0. Times minus 2, that will make it what? Minus 4 plus 9, that will make it 5. From here, I'm getting B. I'm getting B. So I plug it here to get C. So try to solve it the way you like. That C is what? Minus 3 minus 6B, which give me 3. Since B is minus 1. If B equal minus 1 and C equal 3, I can get A. So A will be 2 minus C minus 3B, which is 2 minus 3 plus 3. So the answer is 2. So A equal 2, B is minus 1, and C equals to 3. Just want to be sure I not do any mistake. Yeah. Yeah, 2. So I have T is what? A is 2, that will be 2U. V is minus 1, minus V plus 3 W. So I have this relation, this linear combination. Okay, the last one, I tried this in terms of these vectors. Did I do it before? No. Okay. Now, just to be sure about the calculation, this is where I will stop. Then next video, I will talk about subspace. Okay, so I need to write M, call it M, call it T, the way you like. So I need M as a linear combination of this vector, BU, AU plus BV plus CW, which would be these equations. A plus 2B plus C is equal to 4. And they have what? 3A plus 8B plus 7C is equal to 20. Well, 2A plus 7B plus 9C equal 23. Okay, so I get rid now of the coefficient of A like what we did before. Actually, you can solve it the way you like it. Multiply by minus 3, this is 0. By minus 3 and add, that will be 2B. By minus 3 and add, that will be plus 4C. By minus 3 and add, that will be 8. Correct? Yeah, minus 12 plus 20, that is 8. Now we get rid of 2A, multiply by minus 2 and add, that will be 0. Minus 2 and add, that will give me 3B. Minus 2 and add, that will give me 7C. Minus 2 and add, it will be 15. Correct? Minus plus 23 is 15. I can get rid of these two, divide by 2. So I have A plus 2B plus C equal 4. That will make it easier for me to do the calculation. Plus 2C equal 4. I have 3B plus 7C equals 15. So I'm getting what? A plus 2B plus C equal 4. This is the same. Now multiply by minus 3 and add, that will be 0. Minus 3 and add, that give me C minus 3 and C equals 3. If C equals 3, plug it there. So I have B equal 4 minus 2C, which is minus 2. Plug it there. So I have A equal 4 minus 2B minus C. B is minus 2, so I have 4 plus 4, that is 8. Minus 3, that gives me 5. So M will be 5, 2, which is A, and B is minus 2V plus 3, W. 5U minus 2V plus 3, W. That will be N. Yeah, I think I will stop here. We concentrate in what? In two things mainly. Yeah, how to show they are linearly independent or independent, either through the determinant, and if there are three vectors in R3 and they are linearly independent, then they form a basis. Sometimes you want to show a basis. And the other things, what's the meaning of linear combinations? How to write W in terms of the other vectors. If they are dependent, then it means they can write W in terms of the other two. If they are independent, it means any vector. If there are three vectors in R3 and they are independent, it means they form a basis. It means any vector in R3 can be written as a linear combination of those three. Let me stop here. Yeah, I don't like to have a long video. So let me stop here. Let me stop the recording. And then I will try to do another video later about the subspaces. Thank you.